All right, let's talk about one of the most stressful things you can do in software engineering, changing the database of a live application. Seriously, it's like trying to perform open heart surgery on someone while they're in the middle of running a marathon. It sounds impossible, right?
This quote from our source material just nails it, doesn't it? For any modern service that needs to be always on, you can't just put up a closed for renovation sign. Your users expect it to work all the time. So yeah, how do you rebuild the foundation while the building is still packed with people?
You see, we've got this clash of two worlds. Back in the day, we had maintenance windows. We just take the whole app offline, maybe in the middle of the night, run our big, scary scripts, and just hope for the best. But in today's world of rolling deployments, where new code is always shipping, that old approach is just a total recipe for disaster. Okay, so to figure out the solution, we have to get really specific about the problem. And it all comes down to that rolling deployment. For a little while, you have two different versions of your code. Let's call them V1 and V2, both live, both running, and both trying to talk to the exact same database at the exact same time.
So picture this. Your shiny new V2 code renames a column, say from user_address to delivery_address. The second that change hits the database, every single one of your servers still running the old V1 code completely freaks out. It's looking for a column that, from its point of view, just vanished into thin air. And that's it. Errors start flying, things crash, and you've got downtime. So how on earth do we stop that from happening? Well, the entire strategy, the whole art of zero downtime migrations, is built on one single unbreakable rule. And here it is. This is the golden rule: backward compatibility. It just means that during the entire transition, your database has to be able to happily serve both the old code and the new code at the same time without breaking. Every single thing we do from this point forward is all about maintaining this one principle.
So how do we actually achieve that? Well, the industry has settled on a really smart strategy for this. It's called the expand and contract pattern. It's not magic, it's just a very disciplined four-step process for making these changes safely. First, we expand the database so it can support both versions. Then we bridge the gap by syncing up the data. After that, we switch the app to use the new structure. And finally, we contract the database by cleaning up all the old stuff. To make this super clear, we're going to walk through a classic example, just renaming a column from address to billing_address.
So phase 1, expand. All we do here is make additive changes. We add the new billing address column, but we absolutely do not touch the old address column. Now, the key is this new column has to be nullable or have a default value. Why? Because the old code doesn't even know this column exists. So when it inserts a new row, the database can fill in that new column with a null or a default, and the old code just keeps chugging along completely happy.
Okay, so our new column exists, but for all our existing data, it's totally empty. This brings us to what is, without a doubt, the most critical and delicate part of this whole process, the bridge phase. The goal here is simple: get the old and new columns perfectly in sync. The first part of building this bridge is to deploy some clever new code that does what we call dual writes. It's pretty straightforward. From now on, whenever the application needs to save or update an address, it writes that information to both the old address column and the new billing address column. This makes sure all new data is kept in sync going forward. Now, what about all that historical data? That's the second part of the bridge. While our dual writes are handling all the new stuff, we kick off a background script. Its only job is to go through every single existing row and copy the data from the old address column over to the new billing address column. Once that script is done, the two columns are perfect mirrors of each other. And now that our data is fully synchronized, we get to do the fun part. We flip the switch. We deploy the final version of our application code. This code has been changed to read from and write only to our new billing address column. The old address column is now basically retired. It's still there in the database, but no part of our application is talking to it anymore. The last step is just tidying up. After we've let the application run for a while, maybe a day, maybe a week, and we're 100% confident that everything is stable and we won't need to roll back, then and only then do we run one last migration to finally drop the old address column. We've paid off our technical debt and the migration is officially done. Now, that four-phase pattern is a fantastic theory, but actually turning it into reality without any hiccups requires some real discipline. A great strategy is only as good as its execution, so let's quickly hit on some absolutely essential best practices. First, please always use automated, version-controlled migration tools. You never want to be running these kinds of changes by hand in production. Second, Be super careful with huge tables. Even just adding a column can sometimes lock the whole table and cause an outage. For those monster tables, you'll want to use special online schema change tools. And finally, a really big one, test the in-between states. Make sure your old code works perfectly with the new schema before you ever switch over.
This all leads to a crucial mindset. Keep your changes small and isolated. If you need to rename a column and change its data type, say from a string to an integer, do not try to do both at once. That's just begging for trouble. Instead, you break it down. You do one full expanding contract cycle just for the rename. Then you do a second separate cycle for the data type change. Keep it simple.
When you step back and look at this whole process, it's really about a fundamental shift in how we think. It's about consciously deciding to trade a little bit of speed for a whole lot of safety and stability.
Think about the old way. It was this one big, high-stakes, all-or-nothing moment. We'd hold our breath, run the script, and basically just pray to the server gods that nothing would explode. It was a high-wire act with no safety net.
This new way, it transforms that terrifying event into a safe, multi-step choreography. Each step is small, it's controlled, and it's reversible. Now, does it require more planning? Yes. Does it mean more deployments? For sure. But that is the price you pay for stability and true zero downtime.
Ultimately, this process makes really difficult changes manageable and, most importantly, completely invisible to the people who matter, your users. So I'll leave you with this question to think about. What's the next big change coming up in your own system that you could make totally invisible?